bad things are going to happen and we need to be prepared.
What we did is we pre-treat the house with some gel. By pre-treating that gel, hopefully it's going to absorb some of the heat so that wood siding doesn't catch on fire. But it's not an end-all, it's not the savior of anything.
Actually, a homeowner has decided to stay back and protect his property, which we never recommend. Because what we're seeing right now can come up on us within minutes.
The disruption and destruction that follow the path of a forest fire can never be underestimated. For example, we can look back to May 2016, where nearly 90,000 people were forced to evacuate their homes due to the oncoming inferno of the Fort McMurray wildfire. This wildfire would lead to $10 billion in damages, including the destruction of 3,200 homes and 590,000 hectares of land. It can be seen by the rising number of forest fires per year that some factor is causing a frightening change in the landscape of wildfires. That factor is climate change. Climate change has been increasing the temperature and will continue to do so, causing a less humid environment and in turn an upsurge of dry flammable fuel for these wildfires to build themselves upon. This loop shows the importance of stopping forest fires, as if we can lower the rate of forest fires, we in turn lower the rate of climate change per year. This is why we have chosen to invent something that will lessen the impacts of forest fires and help protect our trees and homes.
Our newly developed technology will be applied to the outside surrounding parameters of the fence to ensure the safety from wildfires. In BC, fires are no joke, and having this extra buffer to keep you safe and alert from fires provides you with that extra security. It will also give first responders extra time to act upon fires, keeping your property intact for the time being. It is vital to be able to keep our rural communities where forest fires are common safe and intact from the threat of destruction. We want to enhance the ability to keep your livelihood safe with the development of our new technologies.
This is our SolidWorks model. The boxes sit on a wooden post with a hose running up the side. A small door opens when the signal is received, which reveals our sprinkler. On top of the boxes, a mount for a solar panel is connected to two servos rotating on two axes. The indicator lights and sensor are located on the side, with the light turning green if the sensor detects a fire. Below, the hose attaches a pipe directly feeding the sprinkler.
As shown in the SolidWorks model, our project consists of these two main boxes, with a solenoid down here, a servo right here, and a solar tracker on the top. By removing a sealed waterproof lid, we get access to the electronics, which you can see mainly composes of these two Arduinos. This Arduino controls a solar tracker that's placed on top, which uses two servos, here and here, as well as 4 photoresistors that are placed on each corner of this board. By taking readings from the photoresistors, the Arduino positions this board such that all the resistors have the same maximum reading. This ensures that the board is pointing towards the brightest position. For the budget we had for this project, it wasn't feasible to get a good quality solar panel that would sit up here, with addition to all the other parts that we needed. But it should be easy to see that all we'd need is to place it up here with an additional set of wires running into the electronics box, which would trickle charge this battery that powers the solenoid. We'll now move on to this Arduino, which has a slightly more complicated role. This temperature and humidity sensor mounted on the side sends constant readings to the second Arduino. If it ever reaches a point where the temperature is higher than humidity, it goes into red mode. That's when it senses a wildfire. When the Arduino senses a wildfire, the first thing it'll do is turn this red LED on, and then this buzzer, which plays a simple alarm. It'll also open this door, and after a 1 second delay, it'll turn on the solenoid, which lets water flow up into the sprinkler.
We chose to do this for our final design project because wildfires are a problem very close to home. BC is hit with constant wildfires every summer. and it just happens to get worse every year because of global warming. So we invented this to hopefully give people who don't have immediate access to a fire department an extra buffer to defend against that fire.